We'll come back to the channel. Okay. So we're going to look at another example on Laplace transforms, and it involves an initial value problem with a step function. Okay. So for our initial value problem, a y prime prime plus 2y prime plus 5y, we have been given these initial conditions right here. And one thing that you observe is that, unlike the two previous examples that we have done, of which you can check the link in the description, they were starting from zero. It's more like you had, let's say, y of 0 equals to 1, like the initial starting point is 0. But for this one, the initial starting our initial point, like the starting point, is pi. So how do we do this? So it's like we have to, it's much easier to find the Laplace transform of a differential equation um, when the initial condition is 0. Okay, like the starting point here is a 0 instead of a pi. So we're going to have to introduce um, another sets of coordinates, if I were to say so, where we are going to solve it starting from 0. It's just more like just a small manipulation, but it's because we want to solve it starting from 0, and it's very simple. So what we do here is that I'm going to introduce let me introduce tau. Let me say my tau. Okay. There you can use anything. I've decided to use tau. Let me say my tau is equals to t. Why am I saying t? Of course, I have to say minus something here, but I'm saying t. Okay. For now, let me show you why I'm saying my tau is equals to t. It's because um, when you find the solution of this one here, you find that I mean, by means of Laplace transform, you are going to end up with something like maybe 1 over s something, and when you find the inverse of that, what you're going to get your answer, it will be in terms of y of what? Y of t. Okay, so what I want to get is, I want it to be in terms of y of what? Y of tau instead of y of t. So it simply means I have to write an expression of tau in terms of t with the initial condition that have been given in the question. So this is going to be minus pi right there. So it simply means my final answer, instead of being y of t or just y of tau, because if I just write that, it's the same as writing that, but I want to show to say it was supposed to be in terms of what? In terms of t, but I've written it in terms of what? In terms of tau. So what's going to happen here is that from this here, you have to write an expression for t. So your t here is just going to be, your t is equals to your tau plus plus your pi right there. So instead of writing y of t or y of tau, your final answer is going to be in terms of y of where there is t, you just substitute with what? With tau plus pi, like that. So this part here, you observe that is equals to what? It's everything is just equals to t. So me writing it in terms of tau is going to enable me to say, instead of me starting from pi, I'm going to start from 0. So my initial conditions will be y of 0 equals to 1. Then my y, by the way, this is y prime. My y prime of 0 as well is also going to be equals to everything that I have, which is my 2e to the minus pi minus 2. So let me also indicate how you can make a mistake here. How you can make a mistake here is thinking that this pi you have to substitute with something. You don't have to substitute with anything, because this right here is just a value. Okay, actually I think this is going to be 1.9 something. If you say 2 divide by 2 divide by your e, okay, 2 divide by your e 2 divide by your e, then you subtract 2. Okay, you subtract 2, your answer is going to be close to 2, but it just be positive 1 point I mean negative 1 point some value like that. So this right here is just a constant, so don't let the presence of this pi right here confuse you. Okay, so the only substitution that you should think of is in the final expression, looking at what you have right here. Okay, what you have right there is that you're going to substitute on the final answer, and everything that's going to be this side as well. Anywhere where where you're going to have a t, you're going to substitute with what? With tau plus alpha. Sorry, tau plus pi, not alpha rather. Okay, so now what will happen here is that, to make this look a bit different, you observe to say I was using y here, and I was as well using y here. So For this one here, I'm going to use that. They call it y tilde or something. So you observe to say you can use anything. I could have chosen to say v of 0 equals to 1, v prime of 0 equals to everything there, but it doesn't really matter how you how you write it. Just make sure to say it's a bit different from the way it was initially. Yeah, and that is just for the sole purpose of you not confusing things when you start bringing back the substitutions here. So even here, what it simply means is that if I'm using y tilde for this part, y tilde prime for that part, here I'm going to have like y tilde prime prime plus 2y tilde prime plus 5y tilde, like that. Okay, so remember to say I'm looking for the Laplace transform of this one here. So how is this one going to be? So this is just going to be like Laplace transform of everything here. Okay, this is just going to be equals to it's more like saying the Laplace transform of um, my y tilde itself, prime prime there, then plus I'll have 2 by Laplace transform of y tilde prime, then here I'll have like plus 5 multiplied by Laplace transform of um, just y tilde there, like that. Okay, so this type of the squiggly thingy that's on top here, don't let that confuse you. I'm just trying to indicate to say I'm no longer using y, I'm using like more like new set of variables. They are a bit different from these, because in terms of y the initial condition is pi, but in terms of this y tilde the initial condition is like it's 0. That's where we are starting from. Okay, so it's much convenient for you to solve, or for you to find the Laplace transform of a differential equation when the initial conditions given are starting from 0. So this is basically what I'm doing right here. Okay, so how you find that is the same. Like it's just more like finding the Laplace transform of the second derivative, the first, as well as just y there. So how this one is going to be equals to that to be equals to, we're still going to have like our s squared right here. So I can choose to write uh, multiply by Laplace transform of y tilde, like that, or maybe for simplicity purposes, and since I don't have enough space, I'll just put capital letter Y, but I'll put tilde there, like that. Okay, then I'll say minus s by y tilde of 0 minus y prime tilde y tilde prime of 0. This is for this sorry, for the first one, for this one here. Then for the second one, which is this one here, for the second term, I'll just have 2 multiplied by, I'll have like s, I'll still use uppercase y there, tilde minus y tilde of 0, like that, plus then I'll say 5 by uppercase y tilde there. Okay, so that's what I end up with. So for this one, I have my s squared by uppercase y tilde minus s sy tilde of 0 minus y tilde prime of 0 plus 2 by s by uppercase y there, y tilde minus, that would be 2 um, y tilde of 0 plus 5 by uppercase y tilde there, like that. So the only thing that you have to do right now is just to substitute for the initial conditions that you have. Okay, so let's go ahead and do this. So here it simply means this equals to, you observe to say is the uppercase y tilde, and this, like, it's common on those points. So this I can write this as my s squared plus 2s 2s plus the 5 that is on the other side, then multiply by uppercase y tilde, like that. Okay, then this is going to be equals to, or maybe before I do that, let me substitute for this part. If you put 1, that's going to be this is s, by the way, so that's going to be like minus s multiplied by 1. That's just going to be minus s. Okay, that will be minus s. Then for this part, how is it going to be? For this part, it's just simply this one here, which is going to be it's actually minus open bracket 2 e to the minus pi minus 2 like that. Then you still have this part again. Okay, you still have that part that's going to be minus 2, because this part is a 1. Looking at what I have here, it is actually a 1. So what else? This is equals to, just leave it like that. So let me try to expand this. For this part, that to be minus s minus 2 e to the minus pi plus 2 minus 2. That goes, you have a 0 there, like the 2 cancels out. So it simply means I have my s squared plus 2s plus 5, then y tilde there like that. So this one here is going to be equals to um, the Laplace of our step function. So let's go ahead and find the Laplace of our step function. But before that, we have to write our step function as we have to write it as a Heaviside function or as a unit step function. So we say this is equals to, or let me just write it as s squared plus 2s plus 5, then uppercase y tilde there like that, minus s minus 2e to the minus pi. This will be equals to g of t. I'm using g of t. That is what is going to be my what? My my unit step, the Laplace transform of the unit step function. But just try to bring this a little bit down like that. Okay. Okay, like that. So let me write this as a step function. So let me say g of t is equals to, so this is going to be 10 sine t multiplied by, that would be 1 minus u of t minus 2 pi, like that. So expanding, this is going to be 10 sine t minus 10 sine t u of t minus 2 pi, like that. So one thing here that you can do is that there might be some method that you might use that might simplify work for you, such that you're like, oh, okay, wait, this is just going to be like, if you look at this part, this has not been shifted by the right amount because this has been shifted by 0. Okay, it's more like you had 10 sine t minus 0, then you have u of t minus 2 pi. We observe to say, okay, I have a 0 here and I have a 2 pi there, so it doesn't be shifted by the right amount. So you can just be tempted to think to say, let me just go ahead and put 2 pi here like that, then u of t minus 2 pi there like that. This might work out, but not every time. Okay, so it's important to say, take things step by step for you to put the actual amount in terms of what, in terms of shifting. So just try to be patient enough and take things step by step. Actually, I'm going to make another video after this one, and I guess the title will just make it like how to make a mistake when finding the Laplace transform of a unit step function. Yeah, so I'll show you the what how how going straightforward like this is might cost you sometimes, because it's not always that things are always going to work out easily. Sometimes it doesn't come in handy. Okay, so what I mean is that for this one here, we have to shift it by the right amount because it's been shifted by 0 and we want to shift it by 2 pi. So to confirm that it's really going to be 10 sine t minus 2 pi multiplied by u of t minus 2 pi, I'll have to confirm using this. I'll say 10 sine t, this part is just okay, minus, I'll say 10 sine, so where there's t here, I'll say t minus 2 pi plus 2 pi there, then you have your u of t minus t minus 2 pi there like that. Okay, so when you look at this part, I have to confirm what this one is equal to using I'm going to use I'm going to have to use addition and subtraction formulas. So let me just try to erase this. I don't think I need it apart from that part. just get rid of this part here so that I create some space. So there's still some interesting parts of this question that's actually coming, so just make sure to say you watch till the end so that maybe what the answer that you're looking for or the part that you're looking for comes and you don't miss it out. Okay, so now the addition and subtraction formulas I'm talking about is a situation whereby, let's say you have sine a plus b. We know that this can be written as sine a cos b plus cos a sine b. So in this case, my a is equals to t minus 2 pi, and my b is equals to 2 pi itself, which is this one here. That's my a and that's my b there. So this one is just going to be equals to, if you say um, sine t minus 2 pi plus 2 pi, this will be equals to sine t minus 2 pi, then cos 2 pi there, like that, plus that's going to be cos t minus 2 pi, then sine 2 pi there, like that. Okay, so one thing that you observe here is that on this part I get a 0. Where am I getting the 0 from? It's because sine 2 pi is a 0, so 0 multiplied by everything that you have here is going to be a 0. Okay, so now cos 2 pi is a 1, is a positive 1, so you just end up with what? You just end up with what you have here at this point. So what this means for me is that how this one works to my advantage is that here this is just going to be this is just going to be equals to, I'll say 10 sine t minus 10 sine, I'll have t minus 2 pi, then I'll have u of t minus 2 pi there, like that. So this is now what I've confirmed. Okay, so it does not always come out perfect like that, to say you just go ahead and plug it in, then you say you substitute by that. So it might need it might need you to use addition and subtraction formulas, more especially when it comes to these trig functions. Okay, so here we have ended up with that. Okay, so you can plug it right there, but before we do that, let me find the Laplace transform of it. So the Laplace transform of this one here, you can just say, okay, your 10 multiplied by the Laplace transform of sine t there, like that, then you're going to say minus 10 multiplied by Laplace transform of that would be sine t minus 2 pi, then multiplied by u of t minus 2 pi there, like that. Okay, so for this part here, I believe it's straightforward for you. That's just going to be 10 over a squared plus 1. Then for this part, this will be minus 10. The Laplace transform of for this part, I'm just using the second shifting here. This is going to be e to the minus 2 pi s. Then divide everything by our f of s, which is or multiply everything by our f of s, which is 1 over a squared plus 1, like that. Okay, so how is this one going to end up? So this one we have said is equals to the 10 divided by a squared plus 1 minus minus the 10e to the minus 2 pi s divide by the s squared plus 1. So I can choose to simplify this for myself by writing it. Since the denominator is common, I'll just write this as 10 minus 10 e to the minus 2 pi s, then divide by a squared plus 1 there, like that. Okay, so that's what it simplifies to. So let me write it here. So that's a squared plus 1, then I have 10 minus 10 e to the minus 2 pi s, like that. Okay, so I'm getting closer to the solution that I'm looking for. Okay, so all you have to remember is that this part is really important to remember because the answer that I might find, it might be in terms of y of t, but it's not going to be in terms of y of t, to be in y in terms of y of um, tau plus what, tau plus alpha. So anywhere where there's going to be a t, you're going to substitute with what, with that y plus pi there. Okay, so for this one, I'm going to write this as my s squared plus 2s plus 5 multiplied by um, uppercase y tilde there, like that. Then this is going to be equals to, I'm going to add these, both these on the other side. So I'll have my s here plus 2e to the minus pi, then that would be plus 10 minus 10 e to the minus 2 pi. Okay, then you divide everything by what, for this part you just divide by s squared plus 1, like that. Okay, so now at this point, it's actually interesting because I'll now have to divide both sides by what, by that. So it simply means my uppercase y tilde is just going to be equals to my s divide by what I have here. But for convenience's sake, I'll have to say I can't factorize this one, but I can complete the square. Okay, so this is actually like s squared plus 2s plus 5. When you complete the square for that part, when you complete the square, this is going to end up to be like s plus 1 squared plus 4. That's what it's going to be equals to. So I'll say this one is being the s divided by that will be your s plus 1 squared plus 4, like that. Okay, so since you can't factorize, just complete the square, and I'll do the same for the other part, which is my 2e to the minus pi. I'll also divide it by the same. So this is s plus 1 squared plus 4, plus, then for this part here, I'll just write it the way it is. Okay, so I'll have like my 10 minus 10 to the e, 10 multiplied by e to the minus 2 pi s. So divide everything by, I have my s squared plus 1, which is this one, multiplying what, multiplying the s squared plus 2s plus 5, like that. Okay, so we're getting closer to the solution that we're actually looking for. So one thing that you observe here is that I can choose to write it this way. Okay, I can choose to write this as uppercase y tilde there is equals to. So for for this part, I believe is straightforward. This part is also straightforward, how you come up with the inverse, because you have to come up with the inverse here. And for this one here, let me show you how you manipulate it. So this one, it's quite evident to say this was more like um, this was more like cos. Okay, this was more like cos. It was more like cos 2t. Okay, but it would be in terms of tau in this case, but it was shifted. It was more like you multiplied it by what, by e to the minus t there, like that, because you know to say when you have e to the 8t multiplied by, let's say, cos 2t, this is supposed to be equals to, you're going to have your s minus your a divided by your s minus your a squared plus what, plus 4 here, like that. So in this case, it simply means my a is a what, my a is a 1. Your a is a 1 there, but it's actually minus 1 since it's coming out as positive there. So how it's going to be is that to manipulate this one, if you observe on the numerator here, I've not subtracted by anything. So what I'm going to do is that I'm going to write this as s, I'm going to write this as s, um, let me write it as s minus, let me write it as s plus 1 minus 1, like that, then divide by everything, like that. uh, Divide by everything, which is my s plus 1 squared plus 4. Okay, so for simplicity purposes, again, you observe to say I can write this as s plus 1. Okay, s plus 1 divide by my s plus 1 squared plus 4, then that would be minus this one here. Okay, That would be my 1 over the s plus 1 squared plus 4. Okay, then you bring everything else that is like plus. So for this part, that's going to be your 2e to the minus pi divide by s plus 1 squared plus 4. Then for this part here, that's the part that actually requires a little bit of work. That's going to be my 10 minus 10e to the minus 2 pi s. So I'm multiplying everything here by, let me choose h of s, like that. Okay, so I have to find what my h of s, I have to write the, I have to find the inverse of this one, because I'm supposed to have in terms of like my h of t, like the inverse of h of s. But instead of me using t, remember this part, always remember that when it comes to such questions. Okay, so what I'll do is that maybe uh like, okay, we already know what this one is equals to. Okay, I believe we know what this one is equals to, because it's more like it was supposed to be e of minus t multiplied by cos 2t. But keep in mind to say this is just the inverse. This is just, I'm just finding the inverse of this, because that's where the answer is going to. So instead of me using t, I'll say like it is e minus, what is our t, which is uh, actually not t, but to be tau. Yeah, it will be in terms of tau. Okay, so this will be e of tau there, like that. Then um, cos cos 2 tau there, like that. Then I'll bring it back and say e to the, what is our tau? Our tau is said is t minus alpha there, like that. Then you come here and say cos 2, where this tau you put t minus alpha there, like that. Sorry, not alpha but pi. Yeah, pi. And you do the same to this one. So what I'm able to observe is that for this one and that one, you are able to find the solution. This one is just going to be sine. This is supposed to be like it's more like it's supposed to be sine. It's actually also shifted a little bit. That's going to be e to the minus tau by sine what? By sine 2 tau. Then you just substitute where there's tau and where there's tau here. You substitute with what? With that one there. And that's actually what is interesting about these ones here. It's like we are taking it back now to the, in terms of what? In terms of t. But we were solving it in terms of tau. That's one thing that you have to remember. So let me just go ahead and find what okay, you do the same for this one as well. Okay. Of which um, and for this one, I think since I've used sine here, so if this is 4 here, meaning I was supposed to have a 2 here. So the only thing that could have made the 2 to cancel out is if I divided this by 2. So there are those little details that you have to pay attention to. Okay, so I've said for this one here is equals to that. Okay, then for this one here is simply equals to what I have down here. Okay, because I've shifted it here is sine, but because I don't have a 2 here on top, meaning I had to divide by 2, because when you find the Laplace of this one, you have a 2 on top, so to cancel out with these 2 here to come back to what? To come back to that there. Then where this tau here is said, you can substitute with what tau is equals to. Tau is equals to t minus pi there. And I wonder, I keep on saying alpha. Okay, my eyes is saying pi, but my brain is saying alpha. I hope you understand. So when time you hear me saying alpha in this video, just know I'm talking about pi. Yeah, so you do the same for this part as well, and you observe to say here you don't have to divide by 2, because you already have the 2 on the numerator there, and that's just going to be more like you have your your e to the don't confuse this e here with this one that you already have here. Okay, so that'd be your e to the minus tau multiplied by this e to the minus pi, like that. Then that is multiplied by sine 2 tau there, like that. So where there is this tau, you substitute what t is equals to. Where there is this tau, you substitute with what what alpha is equals to, which is this one there, and you can go ahead and simplify it. Okay, so actually it's going to be 1, since this that would be like e to the, where this tau, when you substitute with t minus pi, that would be minus t plus plus pi multiplied by e to the minus pi there, like that. And when you fuse the when you, because these are just more like indices, you're going to have like e to the minus t, then you have plus that pi there minus the other pi, because like the bases are the same and that cancels out, so you just end up with e of what, e to the t, then sine 2, instead of tau you're going to put t minus pi there, like that. So this is what you're going to get for this part. Okay, so let me actually do the actual work. The actual work for the what I observed was really the work that was involving for this question. Okay, so for the other parts, it's basically that. So let me find for you, let me help you find for this one here. So all I'm going to do is that, remember to say you have your 10 minus 10 e to the minus 2 pi s, like that. So this is multiplying by your h of s. Okay, so keep in mind to say this, you're going to have more like with everything at the end, this is supposed to be y of tau, but write it in terms of what tau is equals to, like in terms of t. Okay, so all this is like, if you find you can expand it, it's going to be more like 10 h of s minus 10 um, e to the minus 2 pi s by h of what, h of s. So it's like you're looking for the inverse Laplace of everything here. So what I'm going to do is that, since you observe that the most of the work here is just about finding the inverse of h of s, that is what I'm going to find. The other part is just the matter of you substituting and like expanding. Okay, so here's how you come up with what you look at what your h of s is equals to. So in this case, my h of s is equals to this one here, okay, which is my 1 over s squared, 1 over s squared plus 1 multiplied by s squared plus 2s plus 5, like that. So I have to break this one down into its equivalent partial fractions, and I'm just going to write this. Let's say this is equals to, this is going to be equals to, both of these are quadratic, that's going to be a plus bx divided by my s squared plus 1 plus my c plus dx divided by s squared plus 2s plus 5, like that. So when you multiply everything here, remember, I'm looking for the inverse. So when I write it like this, I'm looking for the inverse. So I'm just going to end up with my h of what? My h of tau. That's what I'm going to end up with. That's what I'm looking for in this case. So first of all, let me break it down into its equivalent partial fractions. I see what it is equals to. So when you multiply everything by this denominator here, this is going to be 1 is equals to, you're going to have your a plus your bx, okay, multiplied by your s squared plus your 2s plus 5 plus, that would be c plus d, d dx. And actually, even when I was solving my own work, when it comes to this one here, I was actually making a similar mistake here. I was forgetting, so instead of using x here, you observe that I'm supposed to use c, s, I mean. So this is supposed to be s and that's supposed to be s. Yeah, so that's supposed to be s and s right there. So this is s squared plus 2s plus 5. So the best thing you can think of doing right now is expanding this. Okay, is expanding what you have, because you don't have actual values of x that you can say, okay, maybe x is equals to that. So okay, let me erase that. So we're going to say our 1 is equals to, remember, I'm trying to break this one down into its equivalent partial fractions. So here I'm saying, if you expand this one here, or you expand everything, can take it step by step, what you're going to end up with is you're going to end up with a s squared plus 2as plus b s to the power 3 cubed, then plus um, what else are you going to have, plus 2 plus 2b s, that would be 2bs squared plus 5bs. Okay, then plus that would be cs squared plus c plus ds to the power 3 plus ds, like that. That's what you have when you expand it. And this stage here is one of the most interesting parts. Okay, so what happens here is that this is going to be 1 is equals to, so it's equals to everything, of course, but I want to try to come up with some equations that can help me to find the value of a, b, c, and d. So what I'm going to do is that I'll first of all look at the one that has the highest power. The highest power is s to the power 3. So I observe to say I have some variables this side that have s to the power 3, but on this side of the equal sign, like on my left hand side, I have nothing. I have 0. So this would be more like 0 is equals to, those that have s to the power 3, first of all, is a b, which is this one here. Then the other one is a what? It's a d, which is that one. That's going to be plus what? Um, I'll say plus d there, like that. Those are the only ones that have what? That have s to the power 3. So let me write the ones that have s squared. On this side, of course, my left hand side of the equal sign is nothing. Then on this side you have a, which is from this one, and this one, which is plus 2b, then plus this one, that is what? That is my c there, like that. Okay, so let me look at ones that have just s to the power 1, or just s. On this side you have 0 is equals to, so you have, first of all, have this one, which is your 2a. Then you also have this one here, which is your um, that is your what is this one going to be? Okay, I think I might have forgotten something when I was expanding. So among these, there is one that needs to be 5a. Yeah, this one that needs to be 5a. Take note. So here we have our 2a plus um, plus 5 plus 5b, which is this one here. Okay, so last but not the least are those that have just like constants, like, so meaning you have like the 1, which is this one on our left hand side, equals to our 5a, okay, that I forgot to write, then plus what? Plus c. So just expand what I had previously, like you expand, we had to expand our a plus bs multiplied by our s squared plus 2 2s plus 5. So that 5a that I forgot is when I multiplied this a by this 5, and this is the 5a that I was talking about that I forgot to write. Okay, so now from these we have 4 sets of equations. How do we use this? So I'm going to use this to my advantage, whereby for this part, okay, I'm going to um, is there anything actually that I've forgotten here? There might be one. So for this one, actually, those that have constant, there's also a d here. This d, um, the d from this point, that will be plus d there, like that. Okay, then the last one we say is 1 is equals to our 5a plus c. Sorry about that mistake. Plus c there, like that. So I'm going to use one of the two equations here. I'm going to sacrifice them so that I substitute in the other ones, so that I come up with my answer. So here I'm going to I'll try to let my d be equals to minus b from this one. Then I also use this one here. I'll write it in terms of c. So in this case, my c will be equals to 1 minus 5a. Okay, so I'll pick this equation right here. Okay, that is going to be 0 is equals to a plus 2b, where they c I'll put plus 1 minus 5a. Then I also pick this one here, so that would be 0 is equals to 0 is equals to, I have 2a plus 5b, where there is d I'll put minus what? Minus b. So for this one to be actually minus 1, it will be minus 1. This 1 goes on the other side, so this will be equals to, I'll have minus 4a plus 2b. So this will be equals to 0 is equals to 2a is 2a, that would be plus 4b. So those are the equations that I'm getting. Okay, so these are the equations that I'm getting, and I can erase this part. Erase that part there like that. Even this one, I think. So let me just try to move this a little bit up there like that. And those I might need them, or I will need them actually. So here I can solve this equation and that equation, and let me see what I'm going to get. I have minus 1 is equals to minus 4a plus 2b. Then the other one is 0 is equals to 2a plus 4b. So I can choose to eliminate my a here. It's just these are simultaneous equations, so I can just multiply this by 1 and multiply that by 2. And how is this going to be? When you multiply the second one by 2, that's going to be 4a. Okay, 4a plus 8b. Then what do? You subtract. So this is just going to be equals to minus 1 minus 0, which is still minus 1, is equals to no, you actually add, not subtracting. This is going to be plus, so that will be minus 1 is equals to um, minus 4 plus 4, that's going to be a 0. Then 2b plus 8b, that's going to be 10b. So something that I get here is that my b is equals to um, my b is equals to minus 1 over 10. And remember to say, we said our b, in this case our d is equals to minus b. So you can just come and say um, your d is equals to minus 1 over 10. So your d is equals to positive 1 over 10. So let's go ahead and find the others. Okay, so I can I can find my a from this one, for example. So that's going to be 0 is equals to your 2a. Actually, you can just make your 2a the sum of the formula. Your 2a will be equals to minus 5b minus d. That will be your 2a will be equals to minus 5 multiplied by your b, which is minus 1 over 10, minus d, which is 1 over 10. That will be your 2a equals to 1 over 2 minus 10 mi minus 1 over 10. So you find that your a is going to be equals to 1 over 5. From that, your a will be equals to 1 over 5. Then what about our c? Okay, our c, let's determine what our c is equals to. So from this portion here, my c is equals to 1 minus 5a. That would be c is equals to 1 minus 5. What is our a? 1 over 5. That is cancel like that. So your c is equals to 0. So c is equals to 0. So these are what I find here, and that is. So actually, in case maybe you doubt my solutions in terms of a, b, and c, what you do is that, since we have said our h of s, our h of s is equals to a plus b, bs, a plus bs divided by our a squared plus 1 plus your c plus ds divided by a squared plus 2s plus 5. So you just substitute here all of them. After you substitute, try to make it a single fraction, like try to combine that to make it a single fraction again. You observe that it's just to take you to 1 over a squared plus 1, then a squared plus 2s plus 5. If it doesn't take you to this, it would mean that my values of a, b, and c and d are wrong. But it will take you back to that, I guarantee you. So here it simply means our h of s, our h of s is equals to our a, which is 1 over 5, our b, which is minus 1 over 10, of which I just write as s over 10 divided by your s squared plus 1 plus your c, which is 0, then your d, which is 1 over 10, that would be s over 10 over s squared plus 2s plus 5 there, like that. Of which from this stage now here is very easy for you to come up with what, to come up with your inverse of that is going to be your h of what, that's going to be your h of tau, like that. Then you write your tau in terms of your t, but remember to say you're multiplying this by what? When you expand it, there's a part where you're multiplying it by this unit step function. You have to be careful as well to say, you make sure to say what, you shift it. So I feel like since I've already found for you what your h of s is, like I've broken it down into its equivalent partial fractions, you can go ahead and find your what, your h of what, your h of tau. Just remember to substitute with what your tau is equals to on your final answer, and that's how we answer this question. Of course, it appears to be a bit longer. It's actually very short, even compared to the previous questions that I've done. Just that I'm doing the explanation while solving, so for you to be much quicker, because you don't have to explain to anyone unless yourself. So thank you very much for watching, and we'll catch you in the next one. Bye bye.